Okay, I want to uh, go review wastewater treatment before we talk about septic systems because there's a lot of overlap. It's just conceptually lined up a little differently. So remember that in wastewater treatment, there's the removal of solids. So, a municipal wastewater system receives huge volumes of trash and big stuff that gets screened out. Then they allow gravity to settle heavy things like sand. There's tons of sand, like literally tons of sand in municipal sewage. And then at the very end, the really small stuff settles out. Things that are much smaller, like bacteria, dust. We call this sludge. That's primary treatment when you remove the solids. And secondary is when you reactivate that sludge, feed it a bunch of oxygen so that organic material can be decomposed into compounds, and then those compounds are decomposed into the basic nutrients, the building blocks of life. So you encourage decomposition in secondary treatment. Sometimes you just treat this and release it. Sometimes you treat it and reuse some of it. Sometimes you let this sink into the ground, which is a way of recharging our groundwater supply. And sometimes you do tertiary treatment, which is not very common, but it's uptake of nutrients. So you're not dumping fertilizer directly to the ocean or lake or river. Okay? So those steps are how this is done in wastewater treatment at the municipal level. And a septic system does most of that same stuff, just in a slightly different way. Okay, so you have a house and it dumps all wastewater, so not just toilets, not just turds. Remember that wastewater is a whole bunch of stuff, right? Like laundry water, shower water, dishes water, clothing water. You dump all of that wastewater into this tank that has a really specific design, and the outflow of that tank leaches into the ground. I'll explain. The tank has two separate chambers with a little bit of water flow. And that's important. You have to know that because in the first tank, you have settling of all of the sludge and all the floaty stuff like oils and fats. It's all trapped there. And a little bit of water flows through. Then when that second chamber fills up, it outflows to the output. Keep in mind, this is for a single house. So it's a whole bunch of water. It's a large water volume for a single household's input of material. And you have to scale the septic tank to the number of people in the home. One of the most dangerous things that happens is when people have like an add-on and then they make like a granny unit and 3 folks go to live above the garage, and you don't change the septic tank. If the water flows too fast, you mess things up. Because the way this tank works, and this is where you'll need to label a drawing, in the first part of the tank, primary treatment is accomplished by settling material and by leaving the floaty stuff trapped in that first part of the tank. And you should know that septic systems normally need to be cleaned out every 5 or 10 or 20 years, depending on how many people are using them. Some amount of sand, for example, will accumulate down there, or some amount of fats will solidify up at the top. Apparently, people who clean out septic tanks can tell if you eat meat, because if you eat meat, you crap out fat, and when fat gets into water, it solidifies, and you get like a layer of like solid white fat on top of these. Does that sound appetizing? Secondary treatment is also done in the water because there's like a splash where the water flows in, and that splash oxygenates the water. So, sewage kind of moves slowly through pipes, but when it splashes into the tank, there's gas exchange to make sure that you're activating bacteria. And then when the water flows out, we assume, if everything worked right, that solids were removed by gravity and that organic compounds were broken down into nutrients. Primary and secondary treatment are embedded here. So everything that flows out should be, if everything's working right, nutrient-rich water. And that water is intentionally targeted to what's called a leach field or a drain field, which puts that nutrient-rich water into the ground, presumably where plants are growing. Like when I lived in a geodesic dome up on the mountain, I had this giant ash tree right next to a giant redwood tree where our septic tank drained out into a leach field that helped these trees grow nonstop. Remember that wastewater treatment is basically reverse productivity, right? We go from biomass to compounds to nutrients. So you're fertilizing the heck out of these trees with all this water full of fertilizer. And here's a breakdown of what I just said: primary, secondary, tertiary treatment. And if you want an interesting vocab word, this is basically indirect water recycling, because you're putting water back into groundwater. By the time that reaches your aquifer, nutrients were taken at the surface. The sand and rock in the ground will filter out bacteria and microbes. And so basically you're just putting water back down to the ground so we can drink that water later. And we do all the time. It is possible for these systems to fail. Flow can be too rapid, pipes can break. Or if your leach field is too close to the aquifer, you can get bacterial or viral contamination down to groundwater supply. That is possible. I'm going to make a break in videos.